So here we're going to look at 2018, question 9, part A. There's a few different variations in this one, and this is one of our weird sphere questions. A strange sphere is floating in water. It can be hollow, it can have a separate material inside it. In this case, we need to see what percentage of the buoy is immersed. So, a couple of things we know. The weight is equal to the buoyancy force. Alright, that's the force going down, buoyancy force is going up. This is one of our basic little equations we know. It's floating, so these two balance. Well, the weight of the sphere is the volume at the density by g. That doesn't look too bad yet, but don't worry, there's fun on the way. The buoyancy force is the amount of water displaced. So we're going to say there's a percentage of the water here. Alright, and then V rho g. So this is percentage, and this is referring to water. Alright, if half was, the volume here is going to be the same overall. So let's see, can we put a few numbers on this one? Here's where it gets fun straight away. We know that the volume of a sphere equals 4 over 3 pi r cubed. Alright, it's in your log tables, but you should know it anyway. So we have 4 over 3. Now, we're missing the inner bit. So this is actually 0.7 cubed minus 0.65 cubed. The density, in which case, is 3430, and by g equals what p is for the percentage. The volume is the volume of the outside of the sphere, because that's the bit that's going to push all the water away. So 4 over 3 pi 0.7 cubed. Brackets around there, just make sure we don't have a little boo-boo. Density of water is 1,000. Again, you should know this one. And g. Well, doesn't that look like an absolute bundle of joy? Now, we can begin to make this a little less painful by doing a couple cancellations. So just check that we've got full equations each side. We'll knock out g, and we'll knock out pi. And actually, while we're at it, we can knock out 4/3. Okay, now, without changing anything else, I'm just going to see what I have left in this front. So that's 0.7 all to be cubed minus 0.65 cubed 3430 equals p 0.7 cubed by 1,000. Okay, well that's a little bit less terrifying. And now we want to find p, so let's just sort out our thousands and this guy. So these two can come over on the bottom. We end up with 0.7 cubed minus 0.65 cubed 3430. And we just want p on that side. We'll send these two over underneath. 0.7 cubed by 1,000. Okay. Now the fun part. I'm going to bang these out. If you're feeling ambitious, you can put them all on the calculator in one go. Since I am fabulous at making silly errors, I'm going to do them step by step. So we'll get this guy figured out first. Into our calculator. 0.7 cubed minus 0.65 cubed. 6.5 rather than 5.6 will probably work better. All right. And that is going to be 0.068375. Now, how many decimal points do you go to? Interesting question, you ask. Usually, within a question, I go to 3, but I'm going to make the wise choice here of actually storing this one. So I'm going to say on my calculator here, store into A. All right. And that guy there is in A now. And 0.7 cubed, you just put this in here. 0.7 to the power of 3 equals, we may as well multiply this by 1,000 while we're at it, is 343. oh, look at this, they're being nice to us. All right, and this is going to equal, you can actually see this straight away. That's going to be that 343 is going to cancel. We're going to left with 10 there. Put it in the calculator if you need to, and we will have 0.68. And we'll put it to 375 for the moment, equals P. So P equals 68%. All right, 68% of the volume immersed in water. Ta-da.